Okay, we're going to continue here and continue in lesson 5-7. If you look at this, this is a ratio. We have y to the 1 half, y to the 1 half power plus 1 over y to the 1 half minus 1. Okay, if you think back to the radical terms that we did, for instance, if I had 2 plus square root 3 over 3 square root 2 minus 5. Remember what we did in the last lesson. To get rid of the root on the bottom, when you have more than one term, we had to multiply by the conjugate, which would be 3 square root 2 plus 5, top and bottom. Okay? And then we had to go through and FOIL. Well, really, when you have these 1 half powers, that's like square root. So that's really what you need to do. On the bottom here, I need to multiply by the conjugate. So I'm going to take this off, but I just wanted to relate it to what we did in that 5-6 lesson. So I want to multiply by the conjugate on the bottom here. I want to multiply by the conjugate. So the conjugate of this is y to the 1 half plus 1. So on the top, we're going to multiply by y to the 1 half plus 1. Okay? When I do that, on the bottom, okay, we're going to do our first terms, which is y to the 1 half times y to the 1 half. When I do that, I add exponents. That would be y to the 2 halves or y to the first. Okay, then I'm going to do my outside terms. I'm going to do my outside terms right here. Okay, so my outside terms would be y to the 1 half times 1, so it's plus 1y to the 1 half. My inside terms would be minus 1y to the 1 half. And remember, when you multiply by the conjugates, just to review, those are going to drop out. Okay, because the exponents are the same, they're just fractional exponents. And then for my last term, I am going to get negative 1 times positive 1, which is negative 1. So if you don't even want to write these to begin with, because you know multiplying by the conjugate, that's fine. Now on the top, we're not going to have those outside and insides drop out. Okay, notice we're multiplying y to the 1 half plus 1 times y to the 1 half plus 1. So we're going to have y to the first. Again, adding 1 half and 1 half, one is 2 halves or 1, plus 1y to the 1 half. Okay, then when I do my inside terms, it's also plus 1y to the 1 half, and then my last terms would be positive 1 and positive 1. Multiply them, it's plus 1. All right, so let's clean this up and simplify a little bit. Okay, on the bottom, I get y minus 1. We got rid of the fractional exponent or the rational exponent in the denominator, which we are rationalizing by multiplying by the conjugate. Now on top, any like terms need to be combined. These two right here are like terms. The y to the first at the beginning is not a like term because it's not the same exponent. But I can take 1y to the 1 half plus another y to the 1 half will be plus 2y to the 1 half power. Okay, these two combine to 2y to the 1 half power, but then I still have this plus 1 here. And you cannot go any further than that right there. You can't cancel your y's because you have more than one term on top. Division does not undo subtraction, so you can't cancel the y's, can't cancel the 1's. That would be your answer. Okay, and again, the letters of these are a little mixed up. Just make sure in your notes you are putting them in the appropriate problem. So this is similar to one I did earlier. Here's what we want to do. We have the 8th root of 81 over the 6th root of 3. Okay, I want to rewrite that as 81 to the 1/8 power, and on the bottom I want to write that as 3 to the 1/6 power. Okay, so I'm changing my radicals to rational exponents. Okay, now 81 here can be written with a smaller base. Always write things in a smaller base. I can write that as 9, actually no, I could write it as 9 squared. That's not the smallest base. That actually, 81 is actually 3 to the 4th power. So I want to write 81 as 3 to the 4th power on top. And now that 81 was to the 1/8 power, so this is still to the 1/8. So it's 3 to the 4th, which is equivalent to 81. Notice I put that in parentheses, which creates a power to a power situation. On the bottom, we have 3 to the 1/6. Can't write 3 in any smaller base. Okay, now I'm going to do my power to a power right here. Power to a power, you multiply exponents, so it's 3 to the 4/8 power. On the bottom, we get 3 to the 1/6 power. Now I'm going to simplify a little bit. This is 3 to the 1/2 power, 3 to the 1/6 power. Okay, now notice we got the bases here to be the same, and we're dividing. So I subtract exponents top to bottom. So it's 3 to the 1/2 minus 1/6. That'll be the power. Now, in order to subtract fractions, you have to find a common denominator. So I'm going to rewrite this as 3 to the 3/6 minus 1/6 power. Well, that's 3 to the 2/6, which can be reduced, or the exponent can be reduced, to the 1/3 power. So it's 3 to the 1/3 power. Now, if the problem started out with rational exponents, we could leave our answer like that. But because the problem started out with roots, we got to go back and convert this to the root. So what does 3 to the 1/3 power mean? It means the cubed root of 3 to the 1st power, or the cubed root of 3. So that whole thing simplifies to the cubed root of 3. Okay, let's do this problem right here. We've got the 4th root of 9z squared. So I'm going to write this as 9z squared. Okay, which is under the radical. 4th root means 1/4 power. This base right here of 9, or the 9 there, the number, can be written in a smaller base. We're going to write it as 3 squared. So I have 3 squared times z squared inside parentheses to the 1/4 power. Okay, now I have power to a power, so I'm going to multiply exponents. So I'm going to get 3 to the 2/4 power times z to the 2/4 power. Okay, power to a power says multiply exponents. Let's reduce that a little bit, which is 3 to the 1/2 times z to the 1/2. Both 2/4 there reduced to 1/2. Okay, so notice what you have. These denominators are the same. That means that's the root, so I have the square root. I'll put the index of 2 in there to start with, of 3 to the 1st power. That top one is 1 there, times z to the 1st power. Again, the top one there is a 1. Now, let's clean this up a little bit and look at the best way to write that, which would actually be the square root of 3z. We usually don't put the index of 2 in there, and when these powers are 1 right here, we just write it as 3z. So that whole thing simplifies to the square root of 3z. Alright, one last problem. This is very similar to the one we did earlier. We have m to the 1/2 minus 1 on top over m to the 1/2 plus 1. So I want to multiply by, I got to rationalize the denominator because that's like the square root of m plus 1 on the bottom, except for I'm going to do it with rational exponents. So I'm going to multiply by m to the 1/2 minus 1. So I'm going to do the same thing on top. I'm going to multiply by m to the 1/2 minus 1. Okay, so what do we get? Okay, on top, or let's do the bottom first, actually. That's where we're rationalizing. When I multiply m to the 1/2 times m to the 1/2, that's m to the 1st. When I do my outside and inside, they drop out. Thus why we're multiplying by the conjugate. So it'd be minus 1m to the 1/2 plus 1m to the 1/2, they drop out. But now you have to do your last terms. So a positive 1 here, positive 1 times a negative 1 is negative 1. So on the bottom, I'm going to get m to the 1st minus 1. On the top, we got a FOIL. So m to the 1/2 times m to the 1/2 is m to the 1st. It's m to the 2/2, but I'm going to go ahead and write it as 1 right away. Okay, minus 1m to the 1/2 for my outside. So my outside here. And then the inside would also be minus 1m to the 1/2. And then we have negative 1 multiplied by negative 1, which is plus 1. Okay, let's clean it up and simplify it a little bit. On top, these two right here are like terms. So on top, I'm going to have this m to the first, or m. This is going to be minus 2m to the 1/2 power, and then I have plus 1. Okay, now really that means m minus 2 square root of m plus 1, but because the problem was written with rational exponents to start with, we can leave our answer, or we want our answer, with rational exponents. And then on the bottom, I have m minus 1. And you cannot do any reducing from here. You can't cancel your m's because division doesn't undo the subtractions and the additions between terms on the top and bottom. So that is as far as you can go, and that would be your answer for this problem.